Hello everyone. So today we'll be starting a new topic, which is transformation geometry. There's a couple of questions here at the beginning of the book, and it just asks us about the drawings show different types of transformation geometry, and then it says label each drawing using the following: translation, axial symmetry, rotation and central symmetry. We're just going to focus on the first two for these two videos, so translation and axial symmetry. So if we look at these ones here, translation is just transferring these points a certain distance away from the original points. So this one here is translation geometry. We're moving every point an equal amount away from where they are. So A moves to A1. These other points move the same distance as A to A1, and we get this shape again. So that there is translation. Translation there. And then the other type of symmetry that we have then is axial symmetry. This is where it's like a mirroring image from one side of an axis to the other. So this one here is axial symmetry. We mirror this triangular shape or lamina here across this central line to the other side. So B becomes B1, A1 and C turn to C1. So that's axial symmetry. There. So what we'll do is move on to question 10.6 down here in the graphic solutions book. And this question says, the drawing of the letter T is given above. Transformation is applied to the letter as shown in the figure on the right. So this figure here shows us roughly what's going on. Construct the image of the figure under a translation from A1. So that's what it's asking us there. So I've already made up an image here, A to A1, the first one that we deal with. So this one here shows a T figure. So what we're going to do is, I made this one here 60 and I made it 70 high. It doesn't really matter, you can use the book for this one anyway. So locate point A1 is the first thing you have to do. So if we call this point here A, we can actually label all the points that were here. So we call this one B, C, D, E and F. So next of all, what we have to do is bring a line up 45 from A. So 45 there. And I'll just bring a rough one across the page then from that. Anywhere. So if we bring a 30-degree line then from A, it strikes this line here. Let's get a darker pencil for that. Strikes it here. So that's our point A1 there. That's A1. B falls on the same axis here. On the same parallel, it's parallel, that line is parallel to this one, so we can bring up B, hits it here, E1. We can do the same then for C, but C would fall on a different line, so we can bring up the lines anyway from C and all the other points. Some distance, don't worry about the distance yet. any distance at all there. Some reason. Right. So we have A and B1. So whatever distance that is there, 60, should be 60 here. And it is. So what we can do is we can have in this line between those 2 points. Now the next thing we need to do is get our compass. Now whatever distance this is from A to A1, it will be the same now from B to B1. Yeah, same. So then what we can do is we can mark T here, C, there, F, and D. These lines should be horizontal, which they are. I have 2 extra points. I have E, F, so I call this one here G and H actually here as well, because there's 2 extra ones there, so I bring those 30 degrees as well from this T figure. Any length, doesn't matter. G and H. I'll use the same setting on the compass again, I won't change it. So this line, G and H. So that'll give us a distance then between G and H. So as you can see here, from C to H we join that. From D to G we can join that. G is this lighter line here, so actually there now, yeah. So I'm bring that across. I can bring up these lines then from A1 to D, from B1 then to C. So this is C1 and this here will be D1. Then we've H1, E1, F1, G1. And then we can bring the lines vertically to join the points. And that's translation geometry, so straightforward, and it's there's no tricks to translation geometry, very easy to do. Thanks.